Okay. I'm going to make sure my pen's working here. All right. The coordinate plane, just a little bit of review here. Think of this as graph paper in our coordinate plane. We have a horizontal axis. That's our x-axis. We have a vertical axis. That's our y-axis. And if we were going to graph a point on here, let's say we're going to put a point right here, the way that we name that point is the x-coordinate first and the y-coordinate second, alphabetical order. So this is 2 in the x direction, and then it's 3 in the y direction. So this is the point 2, 3. The x-coordinate is 2, the y-coordinate is 3. This is probably review for you, but if you have any questions or anything, just let me know. If we were to put a point back here, we've gone -4 in the x direction, -1 in the y direction, so that point would be -4, -1. And that's how we're going to name different points that are in the coordinate plane. And you can let me know if you have any questions about that. I wanted to make sure I touched on it, but it's probably pretty familiar for you. Okay. What we're going to talk about today are transformations. And what transformations do is that they move, also known as map. A word that we'll use instead of move is map. Those are synonyms. We can say we moved it, or we can say we mapped it. Means the same thing. An image from one position to another. So we're going to take some sort of shape and move it somewhere else. We start with what's called the pre-image, and we end with the image. So we don't have an image and a post-image. Instead, we have a pre-image that we start with and an image that we end with. What I mean, and the way that we're going to denote that is, let's say we have triangle ABC that is our pre-image. Then after we move it, we would call it triangle A prime, B prime, C prime. Essentially, each one of those vertices has been moved. And since we moved it, we put that apostrophe on there. And the way that we refer to that is as A prime. That's how we'll describe that. That's what that apostrophe means, is this A in this image, or excuse me, this A prime in this image came from A that was in the pre-image. We're going to look at 3 different types of transformations. We're going to look at translations, reflections, and rotations. Those are the 3 different types of transformations we're going to look at today. And in a more sort of young student-friendly language, you will know these as translations, reflections, and rotations. But if you were working with students, instead, you might just call them slides, flips, and turns. So those are going to be sort of our synonyms. For translation will be slide, for reflection will be flip, and for rotation will be turn. Let me know if you have any questions about any of those before we dive into these transformations. Okay. What a translation is, remember, that's the one that is a slide. We are going to take some shape and we're going to slide it. And we're going to go in a certain distance and we're going to go in a certain direction. And often that direction will be given to us by a vector. So here we see triangle EFG on this coordinate plane, and we see this arrow up here. That is our vector. That's going to tell us how we're going to move this triangle. We are going to translate it using that vector. And the way that we do this is we look at that vector and we see that it has a starting point here and an ending point there at the end of the arrow. And basically what we're after is, well, what is that vector telling me to do? And it's going to the right 1, 2, 3, 4 spaces, and it's going up 1 space. And so that's how I'm going to move this triangle. I'm going to take that triangle and I'll move it 4 spaces to the right and 1 space up. Now, moving the triangle sounds kind of complicated, but instead of moving the triangle, I can just move those vertices. I'm going to take And you could start with any one, it doesn't really matter. I'm going to start with E over here. And I'm going to move it 4 spaces to the right and 1 space up. And then that is where E prime is going to end up. I'm going to do the same thing with the other vertices. F, I'm going to move it 1, 2, 3, 4 spaces to the right and up 1. And that's where F prime is going to go. The only reason I didn't put E prime on there yet is because I need to draw my triangle. And then G prime is going to be, well, to get G prime, I'm going to go 1, 2, 3, 4 spaces to the right and up 1, and that's where G prime is going to go. And then I can redraw my triangle. Doesn't have to be a work of art. And now I have E prime, F prime, G prime. And what I've done is I have translated or slid this triangle from here to there using the vector that I was given. That's a translation. We're going to take something, we're going to slide it, and the way we're going to slide it will be told to us by some sort of translation vector. Let me know if you have any questions on what we did there before I have you try one. All right, here goes. We've been given triangle EFG. I want you to perform the translation that that vector tells us to do, and I'm going to set up a poll for this and have you tell me where would E prime be. So I'll set up a poll that will be asking you about E prime, but go ahead and draw the whole triangle. So I want you to be able to do the whole translation, but the question here is strictly, where would E prime be? If you have trouble with the coordinates, then it's okay to let me know that. Summer, the prime is, oh shoot, close my poll by looking at it. Oh, no, I didn't. We're good. Prime is where it goes after we move it. That's the image. Right now, EFG is our pre-image. E prime, F prime, G prime will be our image. So where E goes to is called E prime. We'll go another 15 seconds on this, but the answers are not flooding in. Okay, let's take a look. Please don't make these harder than they actually are. That could be what's happening here. All right, so we are going to move this triangle. And the way that we're going to move it is by using the translation vector we've been given. This vector here, oops. This vector down here tells me how I'm going to move every point on my triangle. The way that I'm going to move it is by moving the vertices. But I can see, let's see, I went down 2 and to the right 3. So that's how we're going to move every point on this triangle. Really, we'll just move the vertices. Down 3 and to the right 2. And so starting with E, since that's the one we were after, if I need to go down 3 and to the right 2. I'm sorry, I did it backwards. Down 2 and to the right 1, 2, 3. E prime is going to end up right there. And the point that E prime is going to end up with is -1, 1. That's where E prime is going to be. Down 2 and to the right 3. Then we're going to do the same thing with every other point on here. F is going to go down 2 and to the right 3. So F prime is going to be right there at, let's see, -1, 3. And then finally, G prime is going to go down 2 and to the right 3. So G prime is going to be over here. My new triangle, when I draw it in, is going to look like that. G prime would be at 4, -1. And very good, Summer. Yeah, I think, you know, the idea is that this vector over here tells us how to move all the points. We move them. We have our new triangle. So we started out with triangle, and let me do this. We started out with triangle EFG, that was our pre-image. And then after we move it, we end up with triangle E prime, F prime, G prime, that is our image. And we can find the coordinates of each point, because that's how we're going to move our triangle. And that's a translation. That's a slide. You can sort of visually imagine that triangle just being slid over to the new position. Up next, reflections. A reflection is what we might call a flip. Whenever we do a reflection, there's going to be some components to that. There's going to be a line of reflection that we're going to use in order to create the reflected image. We're starting with a pre-image, finishing with an image, same as we did before. Here, my image is an L, and I'm going to have my pre-image is an L. I'll have an image after I perform the reflection. You can imagine that this L here is just really, really wet ink, and you fold your paper along the line of reflection, and what you get when you're done is the image, and that would be correct. You would flip and have L like that, and we just did a reflection. For some people, that visualization works really well, the idea that, okay, when I imagine myself folding my paper, how's it going to land over there? If that doesn't work great for you, that's okay. People who are sort of artistic and visual, that usually does the trick for them, but not everybody works that way. Some people want more of a process, and your process is this. In order to figure out, and I'm going to go ahead and get rid of that backwards L we had there. In order to figure out where my image is going to end up, I can take a point on the pre-image like this top of this L over there. And if I go perpendicular to the line of reflection, and then I go that exact same distance, that's where that point's going to end up after my flip. And then I can do that with a couple of other points. I could go down here and say, okay, perpendicular to the line of reflection, go the same distance. And then finally, if I do this corner here and I go perpendicular line of reflection, go the same distance, there's where my 3 points are going to end up. So when I finish this and I draw it in, my reflection, my image is going to look like that. So perpendicular to the line of reflection and go the same distance. Here we have a vertical line of reflection. Over on the right, we have a horizontal line of reflection. It's also possible to have a diagonal line of reflection. We're going to see some of that, but our focus is primarily going to be with horizontal and vertical. Diagonal will come up, vertical and horizontal will be our primary concerns. And then just to sort of go back and see, what does this look like if it's just the pre-image and the image, it would look like that. Okay, for the one on the right, again, you may think, okay, my ink's really wet and I fold it, and when I fold it, I end up with this right here. It doesn't have to be perfect. Or you might say, okay, perpendicular to the line of reflection, go the same distance, I'll put a point. Perpendicular line of reflection, go the same distance, I'll put a point. Perpendicular line of reflection, go the same distance, I'll put a point. And then so after I draw this one in, I've got that shape right there. And that's how I reflect across that horizontal line. When we reflect, we will have a line of reflection, and that's how we'll create our reflection. Any questions about what we did there for reflection before I have you try a couple of those? All right, here goes. So we have this triangle here, ABC. That's our pre-image. My question to you in this poll I'm about to set up is, find the location of B prime if we reflect across the y-axis. What this means is that this is our line of reflection. So we've been given the line of reflection in the problem because we're reflecting across whatever the line of reflection would be. And so I'm going to need you to give me the coordinates of B prime after we do that reflection. So we're going to take triangle ABC, that's our pre-image. We're going to reflect it across the y-axis. And after we do that, I want to know where's B prime going to be. All right, let's take a look at this one. Okay, unanimous. Outstanding. Very good. I think the whole idea of transformations is starting to take hold. That's excellent. We're going to take some shape and move it. We might translate it by using a vector. Here, we're going to flip it by reflecting it across some axis. The poll went perfect, so I won't spend a ton of time on this one, but I do want to just make sure that we kind of show what happened here with our reflection. So what we're going to do is we're going to say, all right, then I'm going to reflect this across the y-axis, so that's my line of reflection. Make sure to identify the correct axis. That's really important. And then when I reflect this, you might just visualize it and immediately go, great. If you can do that, fantastic. I tend to be a little bit more, cautious with my ability to visualize. I'll go perpendicular, same distance. That's where B prime is going to be. That was the poll question. That's 1, 1. So that's great. C prime, perpendicular, same distance. C prime would be up here at, let's see, that's 1, and then 1, 2, 3, 4. That's where C prime would be. And then finally A prime. Wow, that's going to go perpendicular, same distance. That's 1, 2, 3, 4. So 1, 2, 3, 4 over here. That's where A prime is going to end up, and that's at 4, 1. I'm going to redraw my triangle. It's going to look like that. And now I have taken that triangle and I've reflected it across the y-axis. Let me know if you have any questions about what we did there to perform that reflection before I have you try one more. All right, here goes. Find the location of C prime when that triangle is reflected across the x-axis. I'll set up a poll for this one too. My instinct is that it's going to go great, but just to make sure. And, you know, reading the X and Y axis, being able to identify a point is pretty important here, because we've got to make sure we can, you know, identify the thing that we're looking for correctly. You might be able to perform the reflection, but then not identify the point correctly. So if you have any trouble with that, make sure you let me know. All right, let's take a look at this one and see how we did. Not unanimous, but close. Let's make sure we clean this up. I think I know what happened, but just to be sure, we'll talk about it. All right, so let's see. What I'm supposed to do here is reflect the triangle across the x-axis. Oh, so my line of reflection's down here this time, so that changes things a little bit. Oh, perfect, Summer, even better. So it wasn't even that, it was just the wrong choice. Okay, so I'm gonna reflect across the x-axis. So B is gonna go down here, that's where B prime is gonna end up, and A is gonna go down here, that's where A prime is gonna end up, and then C, the one we cared about in this one, has to go 1, 2, 3, 4, 1, 2, 3, 4. That's where C prime is gonna be. My new triangle would be here, and C prime is at -1, -4. If you have questions, let me know, but it sounds like we're in great shape. Okay. Some more practice with reflections is kind of going the other direction. Now, what we can see is we have our image and our pre-image. What we want to know is, where would the line of reflection be? So if you, and it doesn't really matter which one you call the image or which one you call the pre-image, we'll just call the dotted line one the pre-image. And then the solid one we'll call the image, even though it doesn't really matter. Where would the line of reflection be? And what I'm going to ask you is strictly, and you can just type this in, is the line of reflection going to be horizontal, vertical, diagonal? Which one of those goes with each? And let's start with the one in the middle. So we'll do this one first. What kind of line of reflection would I have for the one in the middle? Excellent. Sunshine, Nadine. And you know, if anybody's not sure, you let me know. If everybody tells me, that's awesome. We would have a vertical line of reflection right here. That's where I would fold my paper to get this to land on itself. Second, let's do the one over here. What kind of line of reflection would we have over there? That one looks a little strange. We haven't really seen that, but very good. All right, diagonal, and it would go right here in between. If you're not sure where the line would go, remember how we do this. Perpendicular, same distance. Perpendicular, same distance. Perpendicular, same distance. Okay, yeah. So this is where my line of reflection would have to be. And I guess finally, for the one on the left, perfect, Brianna, Nadine, yep, we'll have a horizontal line of reflection for that one. That's where we would fold our paper to get this to land on itself. Outstanding. All right. I think we're in good shape with translations. I know we're in good shape with reflections. That's terrific. So we've done our slides, we've done our flips. Now we'll do rotations, which are our turns. We have 3 different types of transformations that we're interested in. Rotations are probably the most complicated of the 3. Even though I don't think any of them are that bad, I do think rotations are a little bit more complicated. Rotations will have a center of a rotation and an angle. So there's going to be a spot that we rotate around, and then an angle that tells us how far to rotate. Our focus is going to be on shapes that has the center of the rotation on the figure. It'll be one of the vertices. It'll be a vertex of the figure. There will be times where we might come across problems where the center of rotation is not on the figure. You'll actually see some of that later today. But our primary focus is going to be where the center of rotation is one of the vertices. So we've got triangle ABC down there, and this says determine the rotation image of triangle ABC if it is rotated 90 degrees counterclockwise about point C. Okay, there's already way more information in this than we've seen before. So we're going to rotate 90 degrees counterclockwise about point C. Since we're rotating about point C, that is going to be our center of rotation. That means that point is not going to move. If you imagine like a clock and you put your finger right where the hands start, and you could spin the clock around, but that point where your finger was didn't move. That's the center of rotation. That's the thing that doesn't move. And so what we're told here is that point C is not going to move. Okay, so now I want to rotate this thing. I'm going to rotate 90 degrees. We'll get to that in a minute. Counterclockwise. Got to make sure we know which way that is. So clockwise is this way, the way that the hands on the clock would move. And then counterclockwise is the other direction. So I'm moving this thing counterclockwise 90 degrees. Nice thing about 90 degrees, and a reason that we're going to do a lot of 90 degrees, is what 90 degrees for us is going to do is take our horizontal lines and make them vertical, take our vertical lines and make them horizontal. You'll see it when we do it. Essentially, I'm going to rotate this thing 90 degrees counterclockwise, so we're going that way, 90 degrees. Okay, 90 degrees. Well, 90 degrees means if I currently have this vertical line here from C to A, if I'm going to go 90 degrees, then that's going to become a horizontal line from C over here to A prime. Now, I'm not sure I see this yet. Well, I have this line here from A to B that's horizontal. If I rotate 90 degrees, now that line's going to become vertical from A prime to B prime. And now I have all the vertices I need to make my triangle. And I just took this triangle and I rotated it 90 degrees counterclockwise around point C, meaning point C didn't move. So my new triangle would be A prime, B prime, C, since C didn't move. It wouldn't be wrong if you called it C prime, because it is kind of, it is a point in the image, but you could call it C or C prime because it's in the same position. Let me know if you have questions on how we did that rotation to move triangle ABC to triangle A prime, B prime, C. Outstanding. Very good. Rotations can sometimes be a little fuzzy. Sounds like we're in a good place. All right, I want you to practice this. I'm not going to make a poll for it. I just want you to take a couple of minutes and determine the rotation of rectangle ABCD if it's rotated 90 degrees clockwise about point A. So we get all the information we need here. Center of rotation, which direction is it going to go? How far is it going to go? I'll leave you to it, and then we'll do it together in a couple of minutes, and I'll give you a chance to ask questions. If you need more time, let me know. Otherwise, I'm going to start working through this, but I'm not going to go real fast. So if you're not quite done yet, I'll probably catch up to you at some point. So I'm going 90 degrees clockwise. First thing I have to do is realize it's going to be that direction, clockwise. 90 degrees means my horizontal lines are going to turn vertical. My vertical lines are going to turn horizontal. And I'm rotating about point A, so point A here is not going to move. And so I'm going to take this rectangle, I'm going to move everything that direction. All right, well, it doesn't really matter where you start, but I kind of think it's best to start things that are going to stay out of your way. What I mean by that is, since I'm going this direction, I'm going to start by moving D to D prime first. You don't have to, but it just helps if things aren't really in our way. And so this line here from A to D that's vertical is going to become horizontal, and D prime is going to end up over there. And now I'm going to work from D. I have this line from D to C that's horizontal. Well, in my new one, that's going to be vertical down here to C prime. And then I'll work off C and go from C to B is vertical. Since I rotated 90 degrees, that's going to be horizontal. So B prime is going to be over here. And then just to sort of make sure from A to B was horizontal, now A to B prime is going to be vertical. And here's my new rectangle over here, because I rotated that 90 degrees clockwise around point A. Let me know if you have any questions on those rotations. Rotations may take a little more practice than some of the others, but I feel like you're in a pretty good place. Okay, we've done translations, reflections, and rotations. Slides, flips, and turns. Now let's see if we can kind of put these all together, and we'll just kind of do them one at a time. You can type it in, I won't make polls. But starting out with A over here, what is the transformation that maps the green pre-image to the purple image? So we're starting with the green pre-image, we're ending with the purple image. What is it that would be done to get you from green to purple? Sometimes there's more than one correct answer. So Summer says reflection. And if we put a horizontal line of reflection in here, and we go perpendicular, same distance, perpendicular, same distance, perpendicular, sure enough, a reflection across a horizontal line works perfectly to move that green pre-image to the purple image. If you imagine rotating, it wouldn't work, because if you rotated this one, so like I said, sometimes there is more than one way to do it, but if you imagine rotating this one, you would end up with your shape in that direction, which is not what we have down here at the bottom, so that's no good. So you can imagine that. And if you tried to slide it, it's not going to change. It's still going to be this way, so that doesn't work either. So it had to be reflection, because the other two wouldn't really work there. How about B? Very good, Summer. Very good, Nadine. I think that's kind of a tough one, but if you think about it, if you just kind of imagine your computer screen kind of turning to the right, this has been rotated. Now, the center of rotation would have to be down here somewhere, because every point moved. You know, the center of rotation would be down here, but essentially we went from 11 o'clock to 1 o'clock, and down here didn't move. Sure enough, that's a rotation. I don't know how many degrees, and I know the center of rotation is not on the figure because every point moved, but that would be a rotation. You're exactly right. And then how about the last one? To go from the green pre-image to the purple image, how would we do that? Very good, Nadine. You kind of knew there was going to be one of each. It didn't have to work out that way, but I wanted it to. This one's a translation. Our vector would just move everything left and down. Exactly. Very good. Let me know if anybody has any questions about any of those. do some more. Okay, now sometimes these can be done relatively simply. I'll do F, but as we look at D over there, what is it that we could do to go from green to pink? So we're doing the same thing. We're trying to map, which means move, the green pre-image to the purple image. How do I get from green to purple in that one? Which transformation do I want to do? Really good, Nadine. I don't think that's that easy to see, but if I try to slide it, it's not going to have the right shape, so a translation's no good. If I try to reflect it, well, if I reflect it this way, that doesn't work. So, all right then, if I rotate it that direction, sure enough, I can get it to land in the same place. I don't exactly know where my center of rotation is going to be, somewhere over here, I guess, but sure enough, that one is the rotation. When I say there's more than one right answer, I don't think it's very obvious, but you could do this one by doing multiple reflections. You could do a reflection across this line and be here, and then do another reflection across this line and end up in the right place. So while a rotation does work there, if you said two reflections, you wouldn't be wrong. You just have to say where the lines go. I do think rotation is probably the most efficient way to get there. How about E? What is it we're going to do to get from green to pink in E? This one's similar to one we saw earlier today. I like the reflection, Brianna, but I'm not sure about horizontal. Where would our line have to go if we were gonna, I agree with you on reflection. Where would our line have to go? Diagonal, very good. No, that's great. That's great. Our line would have to be right here. Because remember, if I wanted to see how this got there, I would go perpendicular, same distance, perpendicular, same distance. And sure enough, my line of reflection would be that diagonal line right there. F, I'm going to do F for you. F is one that involves more than one step. We can't get there in one step. But what we can do here is we can start with a reflection across this line, which would give me this shape. And now I need to move it over there. So I'm going to start with a reflection. Then after that, I'm going to do a translation. I won't pin you down with very many of those, but I wanted you to see that sometimes it takes more than one step to get there. And you could obviously reverse those if you wanted to do the translation first and then the reflection, it would still work. So either direction works. If you were to do a class on that spent a lot more time on this type of geometry, this one over here where you reflect and then translate is called a glide reflection, but I'm not going to ask you that. And so if you want to know it for your own personal knowledge, that's great, but it won't be something we do in class. All right. Anybody have any questions at all on slides, flips, and turns? One little homework note that I want to make, number 3 in the homework. Just translate it. Don't worry about whether or not the image overlaps the pre-image. The question in the book kind of asks you two different